Okay, well, welcome to the webinar, folks. I'm really pleased to be here tonight to talk about getting the most out of computer-aided plant identification. IDing plants from photos is something that I really enjoy doing, and I do it kind of the way that people do, like jigsaw puzzles or crossword puzzles or whatever puzzles, is kind of a way to keep my mind occupied and do something slightly useful while I'm watching a baseball game. And so I'm a little sad to be taking time out of my baseball watching schedule because I think the Giants are on right now, but happy to be here tonight to talk to folks about plant identification, which is a subject that's near and dear to my heart. I am going to start a poll just to get an idea about where you all are as an audience. And we can do this while people are still kind of trickling in. So the first question is if you use iNaturalist and for what purpose. So it's a multiple choice poll question. And so if you do use it, do you make observations? Do you ID other people's observations? Do you just kind of use it as an exploratory tool? And this will also tell me how deep in depth do I have to go into the iNaturalist interface. We also have some videos on our Fire Followers website and some guides on how to get started with iNaturalist if you're one of the folks who don't use it. So it looks like most folks use it, and primarily for making observations. But don't worry if you don't use it. We'll cover some aspects of it, and hopefully you'll get started. And if you do want to get started using iNaturalist for making observations or just exploring what's in your area, or if you want to help out others by identifying their observations. So really quickly for today, and then I'll ask you another couple questions while people are still coming in. I'm going to talk a little bit about learning the common plants. And the best way to do that, you know, the folks who are birding, they have a pretty well-established way to start learning birds. And number one is to learn the birds that you see all the time, learn the common birds. And then you learn some of the key features that you need to look for to see if it's maybe not that common species, but something a little different. And then there are some things that you can look for to see if it's something, you know, interesting. Well, I guess all birds are interesting, just like all plants are interesting. So we'll kind of start on that similar path, and wherever you are on the path to plant identification, hopefully this talk will move you a little further along that path. So we're going to talk about the common flower families. We're not going to really delve into a lot of the woody species, although we will a little bit later in the conversation. We'll learn some of the key features, how to understand some of the relationships between the different families of plants, noticing the little things, and then how to get help from people or computers. I'll give you, 4 cheat codes that'll narrow down the list of plants to just a few family or genera. And then we'll talk about beating the system, so putting it all together, and then give you some resources to maybe dig deeper into identification if you'd like. So poll question number 2. Jose, can you launch that second question?
Yes, give me 1 second. Okay. There we go.
And this is about our Fire Followers project in particular. And that is kind of what is the genesis behind our having this webinar. Is we have a project in iNaturalist and also outside of iNaturalist that is looking at, what is the recovery like from the 2020 wildfires? And it's a little over a year since most of those fires started. The August 16th lightning strikes started a bunch of these fires, and they burn for varying degrees of time. But this field season, we've really been focused on getting folks out into areas that have burned near them to record how the wildlands are recovering. And it's catastrophic for people, but it's not always catastrophic for plants. And so we want to have people experiencing the recovery that's going on around them, and learning about fire and the nature that's near them. So a lot of you have joined the Fire Followers Project, which is great, but about an equal amount of you don't know what the Fire Followers Project is. So hopefully you do know what it is now. And I'm going to get started in the next slide, and then Jose, maybe you can launch the next question while I'm on that screen. So there is a tremendous diversity in California, and everybody knows kind of about our iconic state flower, the California poppy, but California is a global biodiversity hotspot. We are more biodiverse than any other state in the United States, and that includes Alaska and Hawaii. We are home to over 6,500 native plant species. You don't have to know them all. And over 1,300 plant species grow in California and in nowhere else in the world. So they're endemic to the state. So it's great to see what ways folks have participated in the project. A lot of you have made observations. Some of you haven't participated yet, and some of you haven't heard about it. So that's all good. I hope that if you do want to, at the end of this presentation, start to work in that project, that's wonderful. And if not, that's wonderful too. So we talked about learning the common plants and their families. You know, really conveniently, probably the common plants that you are going to see around you, at least some of them will be in the largest plant families. They're pretty well represented throughout the state. I'll talk a little bit about some of the features that you'll need to tell those common plants from each other, the habit and habitat, so where do they grow and how do they grow, the number and arrangements of petals and leaves, and the notable textures, smells, sap, seed. All of those things will give you some clues as to what this plant might be or what it might be related to. We'll also talk a little bit about observations. This is really what the basis of this webinar is about, is computer-aided plant identification, and you can't do that without a computer and sharing your observations online. So a lot of this webinar is also about being lazy but suspicious. So iNaturalist will suggest identifications for you, and you want to kind of double check those. And so the later part of this webinar will be about that. Is there one more poll question to go through?
Yes, and I can send that out right now.
Great. And while you're doing that, I'm going to talk a little bit about the largest flowering plant family in California, the Asteraceae. I'm super interested in this poll question, so it's going to be a challenge for my watching the answers rolling in and talking about the Asteraceae. So generally what we think of as flowers in the Asteraceae are actually entire inflorescences. And there are a lot of subfamilies and tribes in this family of plants. But I've roughly grouped them here. And so in the next few slides, I bunch all of these families into kind of 4 groups. That's not necessarily taxonomically correct, but it is a really good shorthand, I believe, to help you really narrow it down kind of quickly. So I'll share these results. A lot of folks use the suggested identification to narrow it down, which is great. And a lot of folks also double check. And then it's good to know that people who didn't use iNaturalist at the start of the webinar are still not using iNaturalist. So first off, talking about the chicory subfamily. So this is an inflorescence, and each one of these seeds corresponds to an individual flower. We're pretty familiar with these plants. We think of them as dandelions or dandelion-like plants. They have strap-shaped petals that are called ligules, which means little tongues. They're usually yellow, but sometimes they're white or bluish purple or orange, and they have milky sap, which not a lot of plants have. A lot of them are non-native, but there are some beautiful native examples, including this Agaceris grandiflora here shown. So I'm going to go through these really quickly because I've given this piece of the presentation a couple of other times, and we can send out the link to those recordings so that you can get a less hectic run through of these. Another subfamily in the Asteraceae or the daisy family is the aster subfamily. So when you think of daisies, you've got the white petals on the outside. Those are the ray flowers. The yellow dots on the inside, and those are the disc flowers. And so daisies, sunflowers, cudweeds, goldenrods, tar plants, yarrows, they usually have those showy ray flowers that we think of as petals, and tubular disc flowers. The thistle subfamily, we call thistles, they're usually spiny in some way. They're usually red to purple, but they can be yellow, particularly in some of the non-native star thistles. There are some lovely native thistles, so not every thistle that you see is a non-native. We have several rare endemics in the Bay Area and elsewhere in the state. There are several species that don't fit into these three broad categories, but they're not super common, so I'm not going to talk a lot more about them. The pea family, I'm skipping over the Poaceae or the grass family because that's a little more in-depth than I think anybody wants to get this evening. I just don't have the time to wax poetic about grasses the way I'd like. So we're going to talk about beans. There are three broad subfamilies of beans. The mimosa subfamily, so acacias, mesquites, mimosas, they're usually woody plants. They have pom-pom flowers and pinnately compound leaves. Up here in the Bay Area where I am, they're usually non-native acacias, but down in the southern part of the state, you have some beautiful native mesquite and fairy dusters like we see on the left here, and you should be proud of that. The redbud subfamily, so more typical pea flowers, but simple leaves, which is kind of unusual for this family. Western redbud you see a lot in the Sierra in particular and the foothills, and also in landscaping. It's a great landscape plant, but a lot of folks plant Eastern redbud, which makes me sad. The pea subfamily, there are two kind of divisions. This is what we generally think of as, the typical pea flower. It's got this banner up here, and then the wings here, and then it's got this keel-shaped petal. These are all modified petals. There are two basic, divisions of that. One's that where the leaflet, this leaf here, the final terminal leaflet is a tendril, and then lupins and clovers where the final leaflet is a leaflet. So sweet peas and vetches tend to make up the tendril division, and lupins, clovers, milk vetches, lotuses, and indigo bushes, wild licorice, they're each in their own tribe. And lupins and clovers have palmately compound leaves, the others pinnately compound. And so when I say pinnately, this is a pinna, a pinnate leaf, and pinna means feather. So if you think of it like a feather with that central axis or rachis, and then each of these leaflets coming off at the end, this terminal one is a leaflet and not a tendril like it is here. Over here are the palmate leaves, palm like a hand. The lupins tend to have three, but not always, or sorry, clovers tend to have three, but not always. Milk vetches, pinnate, and lupins, clovers tend to be palmate. Just want to shout out tomcat clover really quickly. We have dozens and dozens of kinds of clovers in California. A lot of them are native, and you'll often see 3, 4, 5 clovers, native clovers growing right next to each other. So things to notice for clover identification: the color and shape of the flower a little bit. This calyx, which is this lower set of bracts here, is also really important. And then whether or not it has this sort of involucral bract is what they call it in the key, but this little set of modified leaves. Not all of them do, but it's an important key step. And then actually what the leaves look like can be kind of important. So the Apiaceae used to be called the umbelliferæ, and umbels are the name for the special shape of the inflorescence in the Apiaceae. So umbel, like an umbrella, it has these rays. And so this is a compound umbel, and at the end of each one of these little branchlets is another umbel. So that's what it means when it's a compound umbel. So each one of those rays will support a flower. So if you had a little umbrella that had little flowers at the tips instead of nubbins to keep your umbrella from falling apart. Lomatiums and tauchias. So we're usually pretty familiar with, this is also the parsley family. So parsley, fennel, dill, celery, parsnips. A lot of them are really well represented. If you think about caraway and fennel seeds, you'll know a lot about the shape of a lot of the seeds of this family as well. So biscuit roots and umbrella worts, they're usually low growing, but not always. Compound leaves, or compound umbels and compound leaves, strongly dissected. Fruits are very sweet, excuse me, ribbed. Sometimes they're threads, sometimes they're in broad wings. And very often they're important for identification. These usually have the strongest parsley smell. The sanicles and eringos, they usually have leathery leaves. They're toothed, lobed, or dissected. The flowers don't tend to be super showy on these, and they lack this sheathing stem base, which you can see here really clearly. That's also typical of this family. Their seeds are usually spiny or pointy, but not ribbed, so they're a little bit of an outlier for this family. And then this is a completely artificial designation, but tall white flowered and small white flowered. The small white flowered American carrot and hedge parsley are natives. There are a lot of non-natives that look similar, and we'll actually go through one of them later in the Identotron portion of the talk. Tall white flowered angelicas, cow parsnips, lovage, hemlock, sweet Sicily, yampa, generally over a foot tall, not always, particularly in the yampas. Pinnately compound leaves, almost always white flowers, but not always. And seeds that are smooth, they have ribs or wings, and usually broadly sheathing stems. And where they grow, if it's in a wet site or not, is often important for identification. On to the mustard family. So 4 petaled wonders of the mustard family. Again, 4 basic mustard groups, toothworts and tower mustards. So these ones have basal and stem leaves, and the shape, arrangement, and placement of leaves, as well as the hairiness of the leaves, is really important for identifying mustards. So they'll be toothed to lobed, few or no hairs, generally white flowers. They can fade to pink though sometimes. Their seed pods are siliques, which is a term for a long, thin fruit or a sleek fruit in the mustard family. I'm fond of them as hosts for the margined white and the Sarah orange tip. Rock cresses and wallflowers often grow in rock crevices or outcrops, unsurprisingly. Generally mostly basal leaves, but not always. They're sometimes toothy, and a lot of times they have these fancy branching hairs. And we'll see one of those later in the presentation. Cresses will usually have purple or white flowers, and wallflowers orange, yellow to white. Wallflowers often taller and not in rock crevices or outcrops. Leafy stemmed and fat fruited, those are kind of the other mustards. Pepperweeds, fringe pods, which tend to be white flowered. Watercress, yellowcress, tansy mustard, yellow flowered. A lot of them, or most of them, have lobed or ferny leaves that'll go up the stem, so cauline leaves. Pepperweed fruits will be heart-shaped. Fringe pods, shown here as these lacy circles, also called a silicle, which is another specific term for mustard family fruit. Some of them are more sausage-shaped, particularly the yellow cresses and winter cresses. A lot of the pepperweeds are non-natives, but not all of them are. The jewel flowers and calanthes, basal and stem leaves usually that are toothy, and they'll have simple bristly hairs. And this flower here, most of the color that you see is in the calyx, which is actually not the petals, which is usually the colorful part of the flower. So this is an inflated calyx, and then these things sticking out of the petals. So when I say that they have purple or white flowers, I'm usually talking about this part. This calyx can be yellow or green or purple or black or pink, lots of different colors. Colanthus generally yellow to white. And their seed pods are also siliques, and often the direction that they point and the way that they curve, which side of the stem that they're on can be important in identification. The other four-petaled wonders, the Onygraceae. So this is another large family. Sun cups, we don't tend to have very many of these up in the Bay Area, but we do see a lot of Camisoniopsis, which is in this sort of general group in our burned areas, and particularly down in the southern part of the state, we get a lot of members of this family. The sun cups have a globostigma, which really isn't a stigma, but it's that little ball that you see at the end of the stick that's highlighted here. So that's a fairly easy way to tell that from a lot of the other members of this family. Some of them are leafy annuals, and some of them are rosetted perennials. Clarkias, really showy plants, usually simple leaves and pink to purple flowers. Enormous variety and tremendous local variability, as well as within species variability. So I can usually get it to a Clarkia, not always to species, just because a lot of them are so different or so similar in their difference. Evening primroses, so the ones in the Bay Area are yellow flowered. Down in the southern part of the state, they can be white or pink. Tremendous host for white-lined sphinx moths, and when I was lucky enough to visit the Super Bloom a few years ago, saw a ton of white-lined sphinx caterpillars munching on members of this family. Willow herbs, they're really different in size, from a few inches to several feet tall. Most of them have pink to purple or red flowers. California fuchsia is a really well-known one of these and really common in landscaping. A lot of them are blooming right now, and many of them have these fluff tufted seeds, and they're known as fireweeds for a couple of reasons. Broom rakes and borages, these are actually two very separate families, but I put them on the same slide because they both had the same thing happen to them. And that is members of another family got shoved into this family based on a similarity. So in the totally parasitic and the mildly parasitic, the existing family was the Orobangaceae, or the broom rake family. And they lack chlorophyll, they rely on their host for nutrients. So members of this family are now Aphyllon and Copsiopsis. They used to be Orobanki and Boschniakia, which is my call name on iNaturalist. They can be identified by the number of lobes and potentially by their hosts nearby, which is something that may not come through in a photo. The plants, mostly Castelleas, but also Triphyzarias, and one other genus that I can't recall at the moment, used to be in the figwort family. That family got broken up, and most of the plants partitioned either into this family or into the plantain family, which is pretty interesting because when you think of plantagos, you think of not showy flowers, but most of them are really showy. A lot of the Castellea have the ability to be parasitic. They're not necessarily always parasitic, but that parasitic ability actually shows that they are part of the broom rake family and not part of the scrophs. So the true borages, the Boraginaceae, usually have reproductive parts hidden within the flowers. The flowers can be showy or not. They can be really small in some of the cryptanthas, which means hidden flower. This is a Plagiobothris. And you can see that you don't see any of the reproductive parts sticking out of the flower. So these flowers, usually white in the cryptanthas and the Plagiobothris, which are popcorn flowers, and yellow in the fiddlenecks, blue in hound's tongues, blue or pink in Hackelias and forget-me-nots. And the fruits are called nutlets, which is just a fancy term for their hard-coated seed that's typical of this family. And very often they're needed to identify species, but there are a few things like these rusty hairs on the young calyx there. And then this red staining on the underside of the leaf. This tells me that this is probably Plagiobothris nothifolgus, which is rusty popcorn flower because of these two rusty elements to it. The inflorescence is called a scorpioid cyme, which means it's curled up like this fiddle neck, and Amsynchia, which are the fiddle necks, are really typical of this family. And then what used to be the Hydrophalaceae, the waterleaf family, have that same inflorescence type. So this is a series of scorpioid cymes. You can see down here at the bottom, there are the reproductive parts sticking out. So the anthers and the stigma and style are sticking out of the flower, which is what you usually see. They're not always sticking out, but they're generally always visible where they're not in traditional borages. So phacelias, baby blue eyes, other nemophilas, really just typical of this family or this group. And the flowers are various colors, but usually white to blue or purple. And the fruit in this case are capsules. So I wanted to show you one of the things about Castanheas. There are over, I think, like 135 Castanea taxa in California. There are 67 and 30 Castanea just in the Bay Area alone, and 13 of them are rare. So tremendous diversity. A lot of them can look really similar. And so, for example, this is purple owl's clover. It's got this shaggy, hairy beak. And then this is dense flower owl's clover. So just kind of soft hairy throughout, mostly bald at that beak tip. So that's how you tell those two apart, but really superficially, they look very similar. All right, lilies and irises, these are the two monocot families that I decided to highlight because they're some of the showiest and ones that you'll likely encounter. So lilies on this side, irises on this side. There are two whorls of what's called the perianth, and usually I've been talking about them as the calyx and the petals taken together is called the corolla. In the Calochortus, for the most part, they look very different from each other. So this is one of the tepals, which is an old term for one part of the perianth in this family. And the petals look very different. The petals and the sepals look different. There's an enormous variation in color and form, and I think, I don't remember if it's Calochortus venustus or Calochortus superbus, has one of the broadest variations in flower color that you can see in California. There'll be anything from yellow to white to pink to purple, but they very often have dramatic markings. One of the early blooming plants in California is the fetid adder's tongue, which is one of my favorites. Really strikingly striped plant. In what we think of as more traditional lilies, the fritillaries and lilium proper, both whorls of the flower look similar. So you can see these 6 parts. You can't really tell the difference in them. Most of the time, the fritillaries and lilies will have whorled leaves and pendant colorful flowers. And the fairy bells, which are Prosartes, will be branched and they'll have white pendant flowers. Red Clintonia grows in the redwoods, and then we've got another couple species that will grow in some of the higher elevation areas, but also really striking plants. Irises, so the grass irises, blue-eyed and golden-eyed grasses tend to look like miniature irises. Both whorls of the flower look similar, and so they also appear to have 6 petals. But one of the quick ways that you can tell the irises and lilies apart as a family is that the irises have their petals on top of the ovary, so above where the ovary is. So the ovary is down here or down here. And in the lilies, you can see it's up here above the petals. And then if you turn to this over, it would also be above the petals. So the true irises, most folks can recognize an iris because they're so commonly planted. Those flower parts strongly modified. The leaves and the bracts on this, so these bracts here, and then the length of the tube from here to where it reaches the ovary tip, that length are really key to identification. So just taking a picture of the flower might not help because they're super variable in color as well. And they'll hybridize, which also doesn't help. Okay. Really quickly before I go on to cheat codes, that was kind of a whirlwind tour of some of the common families. Jose, do we have any questions before we jump into this?
Not at the moment. We can continue, and if people have questions, feel free to write them on the Q&A section.
Okay, awesome. Cheat codes. So 4 really basic cheat codes that I use a lot. Whether or not a plant has 3 veins from the base. So most plants have, as you can kind of see in the background here, 1 really strong mid vein, that central vein. But in some species and genera, you'll see 1, 2, 3 veins from the base. And the soft leaf ceanothoses, so not the ones with the hard leathery leaves, but the subgenus Ceanothus as opposed to the subgenus Cerastus, will have those 3 strong veins from the base. The Philadelphaceae, which includes everything from mock oranges to whipple vines, or Western modesty, they'll also be 3-veined from the base. And then a lot of the sunflowers and goldenrods will have this feature as well. So if you're wondering about a plant in the Asteraceae, you see that really strong 3-vein from the base, you know it might be in that tribe. There are also a couple of snapdragon-y plants, so plants that used to be in with the figworts, now in the Plantaginaceae, I think. No, I think they stayed with the spross. Anyway, doesn't matter. They'll have leaves with 3 strong veins from the base. So if that's not apparent in the photos, you can call it out in the notes, and that might help somebody with identification. Plants with milky sap. So I talked a little bit about the dandelion, the chicory tribe, earlier in the presentation. The spurge family, Euphorbiaceae, really well known for its milky latex sap, and also the Apocynaceae, so the milkweed or dog vein family. So that's what those monarch caterpillars, they'll cut that mid vein of the leaf to bleed the poisonous latex sap out and just get enough, but not too much, to make themselves poisonous, but not to actually die from it. And then some of the Convolvulaceae or morning glory family and Campanulaceae, or bellflowers, will have milky white sap. And so there are a couple of herbaceous plants that I'm not quite sure what they are, and I'll pick a leaf and see that milky white sap, and that'll instantly get me to I'm thinking of California harebell in particular. It looks like, just this nothing little herb in the forest, and I'm never sure what it is when it's not flowering. I'll pick a leaf and see that sap and know that that's what it is. The antherifics, so there are a few families that have many more anthers than petals. So roses, we typically think of those, so 5 petals usually, and then just tons and tons of anthers. The buttercup family will do that as well. The difference obviously is mostly in the leaves in those families, as well as the fact that the buttercups tend to be, the ranunculus tend to be yellow. The delphiniums can be very differently colored, but they have super modified petals. So if you have a 5-petaled flower with tons of anthers, it's probably going to be either in the rose family, the buttercup family. It might be a blazing star if it's yellow, or a hypericum. And the leaves can help you further narrow that down. The poppy family, Papaver, some members of that, as you can see in Jose's background, he's got a fire poppy behind him, and you can see that the tons and tons of anthers that plant has. The Cactaceae, you can probably tell from other ways, but they also have that feature. And then the mallow family, if you think of like the Hawaiian icon hibiscus flower, that's a member of the mallow family, and they actually have anthers usually fused into a tube. And so you've got that really prominent crown of anthers that you'll see in those plants. So I talked about some of the four-petaled families earlier, Brassicaceae and then Onagraceae, the mustard and evening primrose families. Most poppies, the non-fumitory members of the Papaveraceae, so that's another family that had two families mashed together. The fumitory family, which contains, everything from Dutchman's breeches and fumitory to our native golden eardrops, which is a great fire follower, and Dicentra formosa or bleeding heart. Those are kind of the fumitory members of the poppy family. The other poppies, which often share that same like ferny look of leaves, will have those four petals, and they'll also have tons of anthers. So it's got a double cheat code on that. Plants in the Lythraceae or the loosestrife family, and some Veronicas, or most Veronicas, which are also known as speedwells, they'll often have flowers with 4 or 5 petals on the same plant, particularly the loosestrifes. And they'll either appear to be or are fused at the base a little bit. So that's when they're not all the way separate down to the base, but they have that slight tube to them. Okay, so we're gonna jump into the next part of the presentation, but I also wanted to pause again and see, it doesn't look like there are any questions right now. I guess we're all waiting to get to the hard part before you ask me questions. Okay, so now I want to talk a little bit about iNaturalist. It does have artificial intelligence-backed technology to suggest matches for you, which is a great feature. It gets better the more plants that we identify and the more photos that it can scan. It's not great at grasses in particular, and some plants it's better at than others. So to add an observation into iNaturalist, you can either do this in the app where you can take photos from your camera, or you can choose them from the camera roll. Or if you come back and download photos to your computer, you have photos on your computer, you can upload them either through a drag and drop or through a browse menu. And then once you do that, you can see I've uploaded a couple of photos here. It'll say, what did you see? And you can either type in something or view the suggestions. And so if you view the suggestions, it will suggest plants to you. And so I did that with this photo where I had, handily pulled up one of the plants and put it on a simple background so that I could better identify it. And that didn't work for iNaturalist at all. So it says, I don't know what you're talking about. Here's some things that it might be. It might be a fern, it might be a moth. I'm not really sure. But it's none of those because I happen to know what I pulled. And it was a little weedy annual carrot. So when I have the plant kind of in situ in the field, it actually does a better job of suggesting identifications. So this is in the carrot family. They're pretty sure about that. They have their top 10 species suggestions. And the ones that are both visually similar and seen nearby are the ones that you're probably going to want to take a closer look at. I'm a little surprised that they didn't also suggest Taurus and Anthriscus, which are two other genera that are, kind of ferny leaved, pretty small, little white flowered carrots in that group that I talked about earlier. There is a way to set this so that it will only show things that are seen nearby, but I'm not going to go into that this evening. So how do you know if the ID that the computer suggests is a good one? So for me, I usually know what I'm taking a picture of, and it's less of a thing for me, but I do often go to places where I haven't botanized before. So I'm not really sure, but I do, I have gone along the path far enough that I recognize families and I recognize relationships, and I know the things to look for in the photos and in the keys or descriptions to make sure that it is the species that I think that it is. So what you want to do is check the features of the suggested plant against the plant that you have either in the photo or in your hand. So Size is something in particular that is not easy at all to tell from a photo, which is why it's great when people put, their hand or a ruler or a coin or something of known size. The tip of a pencil for a really tiny plant can show you that it is actually very small. And that's actually super helpful in identification from photos. That habitat where it's growing. So when people take like a picture of the plant in its habitat, that's actually really helpful for identification. Or if the habitat has changed in some way, particularly in areas that have recently burned, you might not be able to tell what this used to look like. And so if you know that and can put it in the notes, that's also really helpful. I'll also check the leaves. That's a really strong indicator and something that is also really hard to tell for the AI from photos. If they're simpler compounds, so if there's just one leaf on the stem, or if there are multiple leaflets that make up the leaf. So if you think about earlier with the Ceanothus, that's a single leaf on the stem. And then you think about the pea family with its compound leaves for most of that group. Their arrangement on the stem, so opposite versus alternate, is also a really good character to look at. And there are surprisingly few shrubs that have opposite leaves. And that also often really helps narrow it down quickly. And when I say, opposite, they come out of the same point on the stem, whereas alternate, they'll be at different heights on the stem. And then sometimes they'll be ranked differently. So you'll have 2 ranked where they're always on the same side of the stem, or you'll have 4 ranked where they'll be this way, then this way, or this way, then this way. The hairs also often very important. I talked a little bit about the fancy hairs that those cresses have. That can help you get it down pretty quickly. Not a lot of plants have really fancy branched hairs. The leaf margins are another one where it's kind of important, particularly within the rose family. Some of them will have double-toothed or a truncate leaf tip or a glandular edge. All of those things you can usually get if you can zoom in on the photo a little bit. The flowers, obviously enormously important in identification. Their placement on the stem, the number of flowers, the shape of the inflorescence, the color and the number of petals, the calyx, whether or not the petals are fused or free. So that just means are the petals separate all the way down to the point of attachment, or are they merged together in some fashion? So some plant families will have fused flowers, some of them will have free flowers, some of them will have both. And then the ovary placement, which we've talked about a little bit already. And then anything that you notice out in the field is probably going to be important for identification in some way. So if it's got thorns or prickles or scents or textures that may feature in to identification. I talked a little bit about some of the families that, it's really helpful to have seeds or fruit for identification. Roses are definitely one of those. The bark on certain trees, oaks and willows in particular, not the structure of the bark, the texture of the bark can be important in identification. So getting the best ID from iNat, getting the identification as fine as you can or as fine as you feel comfortable, and then you can use the compare button. So if you didn't use the suggestions piece when you first uploaded it, this person just went to, this is a flowering plant of some sort. So if you click the compare on that, it's going to give you, everything that somebody saw in the county. If you get it down a little further, say to family or genus, that button gets to be useful. But you can also use it to just look at the visually similar in the area. So if you click the compare button, it'll take you to another screen, and then you can switch the drop down from observations to visually similar, and that will give you suggestions that look like it. But again, same caveat, it's not necessarily going to be the ones that are from that area. Making notes in your observation that give cues that are not visible in photos for those who are coming along like me to help with identification. Smells in particular are useful in identifying trillium and many mitts. So there are a couple of trilliums that have flowers that sit right on top of the leaves, and the flowers are the same color, but one species will smell like, you know, a spiced tea, and one species will smell like a rotten banana. And it's actually really important in telling the difference. Jeffrey pine and ponderosa pine, if you don't have cones, sometimes you can tell by doing a little scratch and sniff test on the bark. And one of them will smell more like tangerine, and the other one will smell like vanilla and cinnamon. And mints as well. There are many different kinds of mints, and sometimes they smell very different. Well, they do smell very different from each other. So somebody sent me a photo of a mint the other day and said, what kind of mint is this? And I said, what does it smell like? I said, I don't know. It smells like a mint. So smells are not necessarily always the best. But there is a cudweed out there that smells like tutti frutti curry. So if you get the chance to smell plants, do it. So good features or good photos of features that might be needed. So it's great to get one of the whole plant, as I mentioned earlier, one of the upper and underside of the flowers if you have them, and then one of the leaves that shows the attachment to the stem. So this obviously is just a really young plant. You can't necessarily I mean, you have all of those shots in this one photo, except for one of, you know, of the plant's habitat. So you can't really tell much about the habitat from that photo. And then once you get it down as far as you can and have, you know, waited a few weeks for it to get identified further by somebody just kind of breezing through, you can tag an expert if you want. If you think this is an interesting plant that you've never seen before, that's not very common in an area, down here you can see, you know, the top identifiers of however as far as you've gotten it. And it's really great to look through this list and see who's local rather than just tag the top person, because there is a lot of local variability, as I mentioned, particularly with plants that are growing not in their native habitat. So a lot of the weeds from Europe can look a little different here in the US than they might over there. Okay. I wanted to pull up just a couple of observations and do a little bit of this work to see if they are good observations or not. So this first one, the AI identified it as a clover. So it's got this kind of head inflorescence. It does look at first glance like the dried inflorescence of Trifolium hirtum, which is rose clover. But if you can see the leaves, they're in this whorl here, which is another kind of distinctive thing for certain families. So the Palmate and the Rubiaceae, or the skyrocket and the madder family, this is not a clover. So this is something in the Palmoniaceae. So what I can do is suggest an identification, and it doesn't really know. But it does happen to be Leptosyphon ciliatus, which is visually similar and seen nearby. So I'm going to pick that one and hit done. So what I'm going to do is, just to double check, is look for other photos of that. So here's one where the flowers have started to dry up, and you can see that it's starting to look like that plant. If I'm not really sure at that point, I can also go into Calflora and hit search for plants. The Palmoniaceae, and then look at which county it's in, which I think was Napa. And it will show me a bunch of options. So what I'm looking for is a plant that has a nice big head of flowers. That's not whiskery enough. That's not whiskery enough. We're starting to get into the right zone here. So it's almost certainly a Leptosyphon. There's what it suggested. And then we'll get down into the Navaretias, which also have those heads of flowers. These are much more pointy than what we saw though. So we feel okay about that. So let's move on to the next one. This one identified as Rubus Arminiakis, and this is from Sonoma. So I'm going to go back to Calflora. And look at the Rubus of Sonoma. And here are photos of Rubus Arminiakis. You can see the stem is this dark purple. And it's really strongly angled. So you can see that there. It didn't have the really cut leaves like that. White black raspberry. This almifolius. So let's look at that because it's got that purplish stem. No prickles at all, and still slightly angled. So scrolling down a little further, we get to Rubus ursinus. Here's the photo with the round stem, really sparse, really thin prickles. And so we can see that that's Rubus ursinus and not Rubus arminiakis. So we'll do one more and then I think we'll move on, getting close to time. So this one was identified as a ribes. I'm going to zoom in on this photo. And this is a compound leaf. So you can see it's got 5 leaflets. Ribes will have leaves that are really broadly toothed or lobed, but not compound like this. And so I know that it's not that. It looks a little bit like poison oak, but I don't think that it is poison oak. So if I suggest the poison oak family, which is the, well, I'm just gonna, some sort of a sumac. And then I'm gonna go to oh, I remember the family. It took me a minute. And that was in Vacaville is not in Yolo County. Vacaville is in Solano County. So that's too many leaflets. That's too few leaflets, but it does look very similar. And that's really shiny. I know that it's not poison oak because of the way that the inflorescence looks. So I'm going to click on this. And I want to check the description. So there's a link here that's really handy, goes to the Jepson eFlora. And it's got a description of the plant. And I want to look at the leaflets. It says generally 3, which means not always. Crenate to lobed, tomentose to glabrous, which means that it's hairy or not. The terminal lobe or leaflet, we don't have size in the photo, so that's a little problematic. More or less diamond shaped. And then it's got the inflorescence And the flowers, which we don't have. But what we can do is look at more pictures in Cal Photos. And here's one by a reputable botanist with 5 leaflets on it. Here's one that's got that similar looking inflorescence at the edge of the leaves. And so I feel pretty comfortable. Oops, that's not what I want. So I am going to call this Rubus Aromatica and hit save. Okay, so we're pretty much at time. I am going to go to the end of the slideshow. Jose, you want to talk for a minute or two about the Fire Followers project?
Yeah, of course.
Great.
So hi everyone, my name is Jose Esparza, and I'll just take a few minutes just to talk about the Fire Followers project. Andrea at the beginning of the presentation did a good job, but I'll just go over that once more since there are a few people that weren't here. So the Fire Followers project is essentially a community science project that looks to record the responses of plants in areas that were affected in the 2020 wildfires. And we utilize our iNaturalist project, which you can check out in the chat that I just put in there. So there's that, and our project mainly seeks to do 3 things. One, to change the language around wildfires. We mainly focus on the ecological impacts of wildfires while not undermining the social impacts as well. Being that fires are multifaceted and complex, it is important to note that while they can be traumatic for humans, it can actually be a great thing for plants. 2, to activate and educate volunteers to increase outreach to people in science, especially those who have historically been excluded from community science. And then 3, to gather data on fire following plants to compare plants seen before and after fires, increase in understanding in fire followers, and provide crucial information on species of concerns to aid in recovery and conservation efforts. Now, the main question is, how can you get involved, right? There are a few ways to participate. One is just to go out and make observations. So our program utilizes iNaturalist, and any observations that you make within any of the fire boundaries will automatically be added to the project. So it's as easy as making an account on iNaturalist if you don't already have one, joining the project, and then start making observations on iNaturalist. You can visit our website, which I linked in the chat as well. And you can find local burned areas near you that are open around you, and you can venture out, take pictures of plants. And as Andrea showed earlier, people within the community will go in if you don't know what plant it is and sort of either verify or help you identify. And then the other way to essentially help is with identifications. So I myself am aware that outdoor spaces are not as accessible in particularly burned areas. So even if you do not live near a burn site or are unable to access these at the time, you can visit our iNaturalist project and still help with plant identification. So just be sure to comment and identify to help aid others with their observations. And then 3, essentially is just word of mouth, right? Just helping spread awareness of the project and talking to your friends about this. So all the instructions on how to join, how to participate, and how to get involved are on our website at cnps.org/fire-followers. So be sure to check that out. And then also check out some of the challenges that we do weekly, sometimes monthly, as a way to give back to the community. And if there's anything that you are particularly interested in, just make sure you check it out.
Great, thanks, Jose. So that's kind of the end of our time. I'm willing to stick around for a couple of minutes if folks have kind of more pointed questions. You can also reach me, awilliams@cnps.org, or just at me, Bosniakia, on iNat. I'm usually on there for a couple of hours. Anytime there's a baseball game, I'll be identifying plants and watching the game. So that is my leisure activity. So we will have the recording available for folks probably within a week or so after this. We'll send you out probably a link to that once it's posted, and maybe some further information. So one of the folks asked about if groups are going out, and Jose, I don't know if you want to speak to that at all.
Sorry, that kind of cut off. What was the last thing?
Oh, if there are any groups going out, or how folks can find out if there are groups going out.
Yes. So one of the main things is you can feel free to reach out to me via email. And I'll share that in the chat. I know some of our partners do some like outings every once in a while, and particularly the Santa Cruz Museum of Natural History. They do some outings and hikings in the burn sites by Santa Cruz, and then we typically plan some outings every once in a while as well. So just be sure to reach out to me, and I can share, depending on where you're at, I can share some accessible spots, or if anybody else is interested, we can set something up.
Awesome, thanks for that. So I don't see any other questions coming in. Really appreciate everybody's time tonight, and hope that this kind of helped you get more confident in making IDs, or suggesting IDs, or checking your own IDs, however it happens or works for you. So look forward to interacting with some of you on the app maybe, and breezing through your observations. Like I said, I'm Bosniakia on iNat, and I think Jose, your J Esparza, is there a number at the end of it?
There should be.
The nice thing is once you start typing, it'll fill in the rest. So
yeah, you can also just find us on the project if you look at members as well.
Yeah, so I encourage you, if you haven't used iNat, to get on and use it if you want. Join our project, California Fire Followers, and enjoy botanizing. Thanks, everybody.
Bye, everyone.